Hello, my name is deysi alvarracin.
And my name is Roxana Pastoriza, and in this video we'll be showing you step by step how to find the empirical formula from a combustion reaction.
Before we start with the problem, let's go through a brief explanation of what the empirical formula is.
The empirical formula is based on the mole ratio in its simplest form, and it's not the actual number or arrangement of atoms. Here is an example of empirical formula. In this picture, we see where the empirical formula originates from. Let's take a closer look at butane in the picture. If you notice the molecular formula of the compound, C4H10, its simplest form is the empirical formula, which is C2H5. In order to better understand how to find the empirical formula, let's move on to the following problem.
In this problem, what is asking us to find is the empirical formula, using the grams of the products of combustion, which are carbon dioxide and water. Here are some steps to follow. Write out the equation. Find out the grams of carbon, hydrogen, and oxygen by given values. Convert to moles. Divide the moles of each element by the lowest number. Results have to be in whole numbers.
First, start with the equation for the combustion. This step isn't necessary, but you can write it out if it helps with the problem. This equation helps us with a better understanding of how combustion is produced.
Now we have to find the grams of each element of the known compound. We use the given number of carbon dioxide in the problem to find the grams of carbon. We use the molecular weight of carbon divided by the molecular weight of carbon dioxide and multiply it by the given grams of carbon dioxide. Then we use the same steps to find the grams of hydrogen. To find the grams of oxygen, we use the grams of the given sample and subtract it with the resulting grams of carbon and hydrogen.
For the third step, we need the conversion from grams to moles. So we start with the resulting grams of carbon and divide it with the molecular weight of the same element to get the moles. To find the moles of hydrogen and oxygen, we use the same method as shown below. Notice that oxygen has the lowest number of moles, which we are going to use in the next step.
We use the lowest number of moles of oxygen to divide it with the resulting moles of each element to obtain the ratio of the empirical formula. As a result, we get C2H5.501, but if you notice, the ratios we got are decimals and we need them to be whole numbers, which take us to the next and final step.
In this step, in order for us to get the whole number for the empirical formula, we have to multiply it by a number that turns the decimal to a whole number. Here we use 2, which we multiply by the ratio we currently have for carbon, hydrogen, and oxygen. As a result, we get C4, H11, and O2, which is the empirical formula that we were looking for.